Chillers are the heart of large HVAC systems, delivering cooling to buildings, hospitals, and even data centers that power the internet. In this video, we'll explain how a chiller works, the role of primary and secondary pumps, how chilled water is supplied to air handling units and fan coil units, and why chillers are critical for cooling modern data centers. A chiller removes heat from water using the refrigeration cycle. 1. The compressor increases refrigerant pressure. 2. The condenser rejects heat to cooling water or air. 3. The expansion valve drops refrigerant pressure and temperature. 4. The evaporator absorbs heat from chilled water, cooling it down. This chilled water is then pumped throughout the building to provide cooling wherever it's needed. Primary pumps circulate chilled water between the chiller's evaporator and the main loop. Their job is to maintain constant water flow through the chiller, which keeps the system stable and ensures proper heat transfer. Secondary pumps distribute chilled water to the building. Unlike primary pumps, they often use variable frequency drives, VFDs, to adjust speed and flow based on cooling demand. This makes the system more efficient, saving energy while meeting comfort needs. Chilled water flows from the secondary pumps into air handling units and fan coil units. In an AHU, air passes over a cooling coil filled with chilled water, reducing air temperature before it's pushed into ducts to serve large zones. In smaller spaces, fan coil units provide localized cooling, working in the same way but at room scale. Once the chilled water absorbs heat, it returns warmer to the chiller, and the cycle continues. One of the most critical applications for chillers today is data center cooling. Servers generate massive amounts of heat, and precise temperature control is essential to prevent overheating and downtime. In data centers, chilled water is circulated to computer room air handlers, CIHs, or in-row cooling units. Air passes over chilled water coils, removing heat from server racks. Here, efficiency and reliability are critical. Even a few minutes of cooling failure could mean millions of dollars in losses. For efficient operation, balance between the primary and secondary loops is key. Primary pumps ensure the chiller runs steadily. Secondary pumps adjust to match the building's real-time load. This decoupled arrangement reduces wasted energy, improves reliability, and keeps both comfort spaces and mission-critical facilities like data centers properly cooled. To recap, chillers cool water using the refrigeration cycle. Primary pumps keep chiller flow constant, while secondary pumps distribute chilled water to AHUs, FCUs, and data centers. Together, they provide reliable and efficient cooling for comfort and critical applications. If you found this helpful, hit like, subscribe, and explore more HVAC explainers on this channel.